Good afternoon. The previous presentation ran a little late, so unfortunately we're butting up against a break. So I can take at least as much time as I need, and hopefully we won't cut into the break too much. It looks like these are slightly older slides, so I'll make do. Fortunately, I brought notes with me so I can talk around them a little bit. If you looked at the previous presentation, it was a lot of talk about setting, there was some talk about setting the parameters of the pipes, or what's in the pipes. If you think about that a little bit, you want to target specific receivers, but the receivers are changing virtually all the time. So people are looking at different mechanisms or different modes of receiving information. So if you look at ATSC 3.0, ATS 1.0, internet, all of these mechanisms are really different ways of distributing data to those devices. So what this presentation is really about is talking about what's happened over the past and how that's leading us into a future where essentially not only is ATSC 3.0, ATSC 1.0, all of these things are running simultaneously, but somebody's got to manage all that stuff. Somebody's got to figure out who's looking, who's watching, and how all of that stuff is getting to you. And it might be the case that you really want to change that in a near real-time or almost fast real-time case. So let's take a look at a little bit about the history. So originally we had, and this is going to be very top level, the idea here is to just get sort of a general sense of what's been happening over time so that we can sort of get an idea of where the industry is going or where things are going. So that informs us into how we really want to start thinking about how we're going to manage this in the future and how we're going to actually manage getting content from point A to point B being the consumer. So first, if you think about analog TV, what we had a number of affiliate feeds, we had recorded content, we had live content, but all of that was being switched into essentially a very fixed distribution path. So the analog television system was what it was. You had a signal going in, a gazinta, it did what it did, and then you had receivers that just dealt with that. And so all you were switching over time was really just content. So you pick and choose what content you want to send over that, and that's what you're doing. Cable, similarly, you have essentially just picking up that antenna and putting that, merging those all together. But essentially, the distribution paths were fixed, and what you're selecting is what content's going over them. That's going to be a theme in the rest of this discussion. The other point to make there is that while there really isn't any measurement here on who's watching what. So we had a presentation earlier by Nielsen. There's mechanisms of polling, mechanisms of figuring out who's watching. But if you think about it, that feedback really is in a very long time frame relative to what we can do today, for example, if we're connected to the internet. So if you're basically waiting for Nielsen, and clearly they're going to be speeding up that process as quickly as they can, but you're still waiting, and back in the analog days, you were waiting for a very long time to get that information back. And so therefore the decisions based on that information took time, lots of time. So enter the digital TV world with ATSC 1.0. Now we have not just single content paths, we have multiple content paths. It's still statically configured, but the compression allows us to fit more stuff into a broadcast channel. So as you add compression, but you now have more stuff to select from, more things you can put on that compression, changes in the compression that include how much stuff you're doing. So as you can see, the management of this stuff is more complex. And we noticed that when we went to 1.0. You had more complexity, things were harder to configure. If you didn't configure some bits, things just didn't work. And so we built a whole business out of that, is actually managing that stuff and trying to figure out what goes into it and then monitoring what's coming out of it. Similarly, the cable systems, now you actually had transport streams going into cable boxes, and instead of just being sort of the tail on the dog being wagged, it's now can choose and pick and choose what things go in there, and you can actually send different information to the cable system. So yet another different type of, some broadcasters actually having a dedicated pipe to the cable system with different advertising and different content. So then comes the internet, and everything kind of blows up. So Now you have on-demand provisioning where you can actually encode things for the internet and have them stored. You can do live stuff, you can do stream, you can do all kinds of things with the internet. They're sitting out there on a CDN or sitting out in a storage area, or they're being streamed live to a bunch of different devices. And the devices are now choosing what information they're getting. And there's sort of the first time ever, there's a real-time feedback loop where usage metrics on how these things are being used are coming back. Unfortunately, these are really two silos and have been. This is kind of where we are today. Sure, there's some merging that's going on, but at the bottom you sort of see ATSC 1.0 and the MVPDs that we had on the previous slide, and you see that essentially that's sort of the same distribution path. You've still got the MVPDs, you've still got smart TVs receiving over-the-air broadcasts, but now you've gone to this where you can actually have the internet and different things are happening, and really the choice is in these smart TVs. Let me see if I can get the pointer to work. It's easier to point to things. I don't want to use that one. I like using the electronic stuff. I'm a software guy, come on. Of course, it's Windows, so I may not be able to get it to work. Sorry for any Microsoft people. So this is kind of where we are today. So the management is really a static configuration still. We're not doing a whole lot of dynamic changing. And the problem really was that if you look at what the receivers are doing, they kind of don't like it when things get changed around. So on the smart TV side, you can go into the user interfaces in that, you can pick Netflix, you can pick all these different things. But in terms of broadcasting, what's signaled through the stream right now is things such as PSIP and PSI information. And if that stuff changes around, most of the receiver implementations do not like it. They really don't like it. And bad things happen. So what has happened is the configuration of the broadcast has been essentially fixed. The best you can do is change over time how much bit rate you're pushing through a given service. So you'll see PBS, for example, doing things like having an HD service in the evening and cutting back to very low levels on 3 other SD services, dot services, dot 2, 3, and 4, where during the day, those are SDs, and you've got 4 of those all running fairly decent bandwidth, but essentially starving that HD channel. So, and as compression's gotten better, obviously we can fill more and more stuff, but essentially the distribution path is still static, and you're still just choosing what content goes there. So now, enter 3.0 with its pipes. Now you can manage a whole set of pipes, but similarly to the internet, now you can actually change what you're putting into those pipes in terms of the compression, and you can do that all dynamically. And you also have the usage metrics. 3.0 allows us to specify usage metrics, but more importantly, it allows the interactive content to report back in a proprietary fashion things it's discovered about receivers. Now that might not sound very good to some folks in terms of invasion of privacy, but really what it's doing is saying, and you can imagine, we don't have this in the standard right now, but we've imagined a situation where a receiver or even a certain type of receiver could actually provide information about how well the reception is going. So you can actually see that the reception, suppose you had a signal, suppose you chose to basically send out a signaling signal, if you want to call it that, or a signaling broadcast on one of the pipes, the very low level pipe. It's one sort of represented down there in the PLP0. And it's basically just got signaling, and the FEC is set up so it's actually below the noise floor, or near the noise floor, say. Now you can use the receiver's capability to receive that signal to see how well that receiver's doing. And it can communicate that information back. Well, now you have a closed loop system. Now you have a system where the management system is seeing how well receivers are receiving the signal and can make real-time adjustments of those signals. And not to mention, you also have still the ATSC 1.0 and MVPD path. That's really easy for me to say. And again, the receivers are still selecting what content they're interested in. But unfortunately, from a management standpoint, we have many, many, many knobs now. So all the knobs just got added. So now we can see there's a ton of stuff up here that needs to be managed and can be managed in real time. The other thing that's happening in the industry, and I've showed this slide, I think for about 2 years now, and it's still true, and it's just accelerating. And really what's, not only is the management increasing, but everything is going to the web. So everything is going to the cloud. Everything is being virtualized. You can ask any vendor in here. They're all being asked to put stuff on virtual machines, to run essentially on commodity hardware with commodity networks, software-defined networks. That's happening. Every broadcaster is looking into it. Every broadcaster is doing it. That will happen. The nice thing about that is you no longer have to rewire things every time you want to change something. That's the good news and the bad news. Because if you change things, then you have to manage that change and you have to figure out what you're doing. So those management tasks just continue to grow. And the problem here is that we've noticed, and I'm sure folks that have configured plants and done things in the studio side, people don't remember how to use user interfaces. If you go to your PSIP generator, for example, how many of you in here remember how that thing works? I don't remember how it works, and I wrote it, all right? And it's really sort of a testament to the products that are being developed because you don't need to configure them all the time. They sort of, you set them up, you forget about it, and they just run, and they do their thing. And that's true of all the software. All software people are being demanded. That's our demand, you know. I don't want to mess with this thing. I don't want to know how to use this thing. I just want to set it up. I want it to go off and do its thing and let it go. And so that just means the more and more of these systems you get together, the more they're integrated, the more they have to talk to each other, the more opportunity there is for it to all fall to pieces if you don't remember how to do it, if you don't remember how things work together. So centralized configuration, and the thing that some of us that were on S35 will remember, Merrill in particular, and Pete, we talked about a system manager, and it's talked about in some of the other standards you'll see. It's not only is it a good thing to have, it's going to be necessary in the future. It's going to be required because you simply won't be able to remember how to deal with all these other systems. And these systems won't even be local. They'll be someplace up in the cloud. You'll be using a website to control them. So the interesting thing about all of this, if you look at the feedback loop and the things that can be monitored and changed, you'll look up here on the left-hand side, you'll see content selection and encoding parameters. Those are some of the things that a system manager, which is based on, at the top level, you'll see business rules and receiver models. I'll talk about the receiver models here in a bit. But the system manager has to basically define what things are being selected, what content wants to go in, kind of what automation and traffic does now. And in addition to that, encoding parameters. That goes into the content selection and formatting systems. Also, you have the content distribution, path mapping, how that content and the encoding or the formatting of that content gets mapped to or bound to a particular distribution path. And it may be actually multiple distribution paths. You may choose to do different things. You may actually have it going out over the internet in one resolution and over the broadcast in another resolution. You may actually split the resolutions. You may have some high resolution going over one path and low resolution going over another path. All these things are possible with 3.0 and the internet. And you can do this in real time. You can change all of these things in real time based on feedback coming from the receivers on how well they're doing in receiving this information. So in the middle you have the distribution, which we've already talked about, and everybody during this, all these presentations have been talking about, is basically the broadcast, as well as the internet MVPDs, 1.0, 3.0. You can think of those as all commodities, if you will, of things that you want to change and want to be able to deal with. Finally, those go to receivers, and part of that distribution, however, is the costs. I don't want to forget that. Every time you send something over the internet, it costs you something. Power consumption is something you're going to be thinking about in broadcast. So distribution costs are key, and those can be factored in to which pipe you're actually using. Because if you send out an SHEVC stream to the internet, that's going to cost you a lot more bits than if you just send out an SD stream, for example. It's more expensive, just a fundamental fact. Now, those bit costs are coming down, but if you have a lot of people pulling that information, they may be driving faster than if you just use your broadcast, which you're already paying for. So in terms of consumption, the receivers can send back, or things can send back, and now with our interactive content standard that we're just about to put out as a proposed standard, we can talk about, you can write code, JavaScript code and other code that runs on the receivers, on many of the receivers, that can report back information about that environment. Completely anonymous, but really all we're doing is driving a receiver model of how well the reception is happening in the local environment in terms of what channels are being fired, what information is coming back. And you can also get back receiver and user info. So ultimately you want to get to a who's watching in general terms, a very broad general, and how easy is it for them to receive the broadcast. And is there something, so you can imagine a smart system that could be built that would essentially manage this in a smart way. So you have all these models, you have all this big data. Now we start bringing in something that a lot of people have probably heard about is you start talking about machine learning and mechanisms, new advanced software mechanisms that are currently being deployed in a lot of industries. It will be deployed here. There's just no way around it. The question is when. Initially, we think that essentially it's going to move from a static configuration where you're managing the configurations, you set it up, you let it go, and then ultimately it'll move as SFNs are available, as more channels are available, and as the receivers become more intelligent and can deal with changes in the broadcast. Time will tell if the receivers are smart enough to deal with a new PLP update on a minute-to-minute basis, a frame-to-frame basis. We shall see. Hopefully that's the case. I think with the bootstrap in 3.0, I think it's quite possible that receivers will be able to deal with that, so that I'm really hopeful that we'll be able to change the settings of the FEC settings and things on individual pipes over time to actually impact various receivers and target it. So you can imagine a scenario where a receiver's seeing the low-level signaling at the lowest, at the noise floor basically, and it's saying, well, if you could just crank that up a little bit, if you could just crank up the second PLP, I could actually receive that. Or you can make assumptions about how to receive that. So you could actually imagine a scenario where it's lunchtime, a bunch of people have tablets, but you're not really impacting them very much, or you're only seeing a certain fraction of that population. A lot of them are pulling it from the internet, the information you're interested in, say the news, and you're pulling that information from the internet. You could actually be targeting those people with the broadcast because they had receivers, they told you they had receivers, but they can't receive the signal. So you could starve some of the stuff that would be going to a home where nobody's watching, for example. You don't see a whole lot of big TVs watching it because it's during the daytime. And you adjust that so that you start changing the FEC, you starve the bandwidth on the fattest pipe, and you expand the bandwidth on the lowest pipe and improve the FEC, and basically target those receivers on tablets. So this is sort of an idea that's just what would happen in the future, and be able to do a real-time adjust over time the reception capability or broadcast capability so that the reception is improved and different receivers can receive different bandwidth at different times. But we don't see that happening real soon now. This is something that would be ongoing. But in this environment, it has to happen incrementally. So as over time, we'll be managing and monitoring all of these things and just informing our configuration of what we want to do. So business rules that initially drive all of the settings in the system, but you'd have a smart enough machine or a smart enough system that would know, oh, they want these business rules. The broadcaster wants these business rules, so I'm going to set up the configuration this way. And then slowly configure that over time. And then once the closed loop happens, then we would add that functionality over time. So you can imagine this panning out where it's a fully smart system doing this dynamic management in the future, whereas right now, we're probably just going to be looking at a system manager level configuration mechanism. So the idea is ultimately to maximize viewership, maximize people to see your content, and minimize the cost of getting that content to them. Okay, that was it. I got you to break. We have little time for questions. Anybody have any questions? And of course, I'll be around all afternoon if anybody has any questions. We can talk about it. I can talk about this for a very, very long time. I really kind of just gave the most top-level summary at this point. But if you want to talk about it in any kind of depth, I can, as many of people here who have talked to me about some of this stuff know, I can go on for a while. Because I find this exciting. I think involving internet and software technologies to broadcasting, I think, is the wave of the future. And I think that's where this industry has to go. And if we don't, we won't go anywhere. Shark?
Yes, you know, I am not from US. I am very interested by what you propose, in fact, is to balance the amount of content you put on the internet or on broadband instead of to put in the broadcast channel. My concern is about regulation. Is the license got by the broadcaster allows them to do that, to trade off distribution of content from broadband to broadcast and vice versa?
Well, every broadcaster in here is already doing TV everywhere. Well, I won't say everyone, but just about everyone is, and if they're not doing it now, they're thinking about it. So everyone here has, any broadcaster in the room has call it a broadband, or they call it a digital distribution path, AKA internet. I still find it funny that they call it a digital distribution path, but that's just me. So they already had that silo set up in their business operations process. It's really disjoint right now from a lot of the contents moving back and forth, but operationally they tend to be very siloed at this point. The management systems don't know about each other at all, because essentially you've got a legacy system doing 1.0 and MVPDs, and another system doing broadband, internet. And so the leap from going to controlling these two environments is really a business and an operational aspect of things. And that's no small feat, don't get me wrong. That may be harder than the technical aspects of this. It may be easier to build this system and harder to actually deploy it. Does that answer your question?
Yes, because in Europe, I am quasi sure it's totally forbidden, you know.
Oh, not here.
Voilà.
Every broadcaster is on the internet and sending news over the internet. Ask Pete about his daughter's use of Roku instead of the broadcast to get. You told that story at lunch. She would rather use the Roku on their TV than use the broadcast out of the same station. So, any other questions?